they will put features into the software of the fitness tracker that allows it to self-test. Now the end user never sees that, but that function gets used in the factory to validate. Is the fitness tracker working correctly? It might be as simple as it puts a message up on the screen that tells the test person, please take the fitness tracker and turn it upside down. Because inside the fitness tracker is an accelerometer, a sensor that detects movement. Right. And we need to make sure that accelerometer is working. Right. So we can automate a little bit by having the computer determine, did the amount of gravity that we sense change correctly? Right. Or maybe we'll take a little servo motor, like from a remote controlled airplane, and we'll make it flip the fitness tracker over inside the fixture. And now we've automated that, and we save the human factor of having to turn the thing over.
I see. Welcome to Manufacturing Insiders. Today I have Jeremy Willden with me. He is a co-founder of a company called Incredivation, and this guy's just a brilliant electrical engineer. He's picked up programming. He has done some really fascinating projects, sci-fi-ish projects, which I'm excited to talk about your Spider-Man machine. So I'm just really excited to have you on today, Jeremy, and welcome to Manufacturing Insiders.
Great. Thanks so much for inviting me to be on here with you.
Absolutely. One quick note before we jump into it. If you listen to this episode or listen to some of our previous episodes, you enjoy what you heard, go ahead and hit that subscribe button and like the video. Share us with your friends, listen to us on the way to work. If you're interested in coming on Manufacturing Insiders and you're a leader that has some insights to share with other leaders, please by all means go to manufacturinginsiders.com and fill out the form there, and we'd love to have you on. So Jeremy, tell me about this automation system that you put together to develop Spiderweb.
That is one of the funnest projects that we're allowed to talk about publicly. And of course, there are NDAs on a lot of what we do, but occasionally we get to share with the world the kind of projects we work on. And we do everything from extremely simple to extremely complex. But this is one of the more complex projects that we did. It's still been quite a few years back, but we know the machine is still up and running. There's a university not too far from where we operate that has done some stuff that literally comes right out of sci-fi superhero magazines in a lot of ways. They wanted to manufacture artificial spiderweb because spider silk is an extraordinarily strong material. I don't remember what the comparisons are to titanium and other things like that, but it compares very favorably to them. But as you, despite what they showed us on one of the Spider-Man movies where they had a room full of spiders all spinning webs to create artificial spider webs, the spiders are very territorial, and they will actually fight and kill each other off, so it's not a very good way to manufacture them. So this university did some genetic modifications. I know this sounds very sci-fi, but you can find it online. It's really true, where they took the DNA of spiders and crossed them into goats. And you're saying, spider goats? What are you thinking here? And it causes the goat's milk to contain spider silk proteins. It's not that they're spinning webs. It's not that they're slinging around the room or the building like Spider-Man, but the milk contains the proteins. They do some chemistry, and they come up with this little cocktail that goes inside the machine. But what they needed our help with was taking that liquid and pulling it out into strands, very, very fine strands, just like a spider web. Of course, we're not nearly as sophisticated as spiders with all of their great bioengineered features, as it were. So we had to build a machine that ended up taking the space of a couple of these long banquet tables. It has enormous amounts of automation, big touch screens across each of the 3 major stations. It extrudes out that spider silk protein, stretches it out, and as it turns out, a lot of what causes spider silk to be strong is stretching it just the right amount, just the right temperature, under just the right humidity to make the really strong web. So we had all these motors to very slowly and gently handle it because it's super strong, but you still have to be careful with it. Right. We actually have some photos that we could share with you that you could include into the podcast if that makes sense.
Yeah, that'd be super cool.
But it shows the rotating wheels with the spider web going over it, getting stretched and microscopically checked, a small tension sensor, and finally at the end a big spool, and you can it was kind of fun to write all the code to have it spool it up at any angle you wanted, so that the spider web would overlap in a way that it wouldn't stick to itself and tear off. I mean, a lot going on in that process to make that work. So we built that machine, and the university, because we built it in a very open way, we used generally available tools, hardware, and software. They've been able to continue extending it, and as we understand it, they've made it now extrude multiple strands, and we don't even know all the other stuff that they've got going on with it. Funnest project around to build, put the entire machine together, deployed it, set it up, and apparently they've been using it quite successfully.
That's phenomenal. And so that's really a core component of, kind of your business model, is building these automation systems in a flexible manner that the end user can take ownership of and build on, right?
100%. It's one of our core tenets is building things that our customers can continue to work with, and not even just in automation, but when we build products for them, mass-produced products. We intentionally use processes, tools, and technologies as much as we can that will enable our customers to continue working without us. As we like to say, if we all get hit by a bus, we want you to be able to continue working and not be stuck.
Right, exactly. So obviously, not everybody's out there making spider web. What would you say is the most common use case for your pretty broad skill sets? I mean, from the hardware to the software to the circuitry. So I would imagine you could help a lot of different types of companies build custom solutions.
Yeah, we actually started out with our core competency when we founded the company 14 plus years ago or whatever it was actually in adding wireless components to existing devices. We were doing what is now known as Internet of Things long before it was called Internet of Things. We were providing wireless connectivity. So someone would bring to us some type of product and they wanted us to add wireless capability to it. Obviously, that extended a great deal fairly quickly once we got into some of the other automation. But a lot of what we do is making things that connect to Bluetooth to your phone for logging data, enabling additional data collection. So automation in the real world as opposed to automation in a factory setting where it's a very controlled environment.
I see. So can you give me a use case there? I understand the wireless communication, but what would be a use case that some people that are listening might be familiar with?
A lot of things have to do with measuring or instrumenting something. We've done work with, I can't go into a lot of details, but there are companies that we've worked with that their core business involved processing, whether it's food or creating other chemicals for some types of uses, and we'll help them automate the process. They're maybe mixing things in batches and doing things manually, and there's a lot of what sometimes is called tribal knowledge as opposed to rigorously documented processes. And having humans rigorously run a process can be a little tricky. So we help them build equipment that would enable them to automate processes. Now, there are companies out there that design and build that sort of equipment, but more often than not, when you get into some of those big suppliers of equipment, there's an enormous upfront cost. So if you're building 100,000 widgets a month, yes, that automation makes sense because you can drop $10 million on some automation equipment without thinking twice about it because it's going to pay for itself very quickly. But a large percentage of smaller businesses, they really don't have the kind of capital to drop on that kind of equipment. So we help them automate in a simpler, more basic way. We might start with some simple little off-the-shelf electronic circuit and simply automate something that is the most repetitive part of their process. Maybe we're designing someone a Bluetooth accessory that goes with their phone. Now, if they were going into a factory making 1 million a month of them, great, they can buy the big test equipment, no problem. But when you're only building a few hundred at a time, we need to build a test fixture, an automation fixture that's a little simpler that will help them so that they can get good enough margins so that they can grow and scale their company so that they can eventually get into those high volumes.
I see. Okay. So let's say I'm a machine shop, and I have 5 large companies that subcontract work out to me. They vary widely in the size and shape, et cetera, and I got to switch my machines over, et cetera. So how could you help somebody like that? Maybe some use cases there.
So something in that case, there are some shops actually that we've worked with that are machine shops, laser cutting shops, things of that nature. I'll give you an example that isn't something that we've actually done but could fit with what we do. I love going into the laser shops and seeing the automation that they use to cut out parts. But when they're done with those parts, ultimately they need to measure and make sure they're consistent. Now, fortunately, the laser cutting machines are amazingly consistent, so you tend not have to do a lot of measurements like pulling out the calipers and making sure that the cut dimensions were right. Then again, if you get a batch of metal that happens to be a little softer than the last batch of steel, the laser might overcut. You might get a little bit more goo sticking out of the edges on those laser cut edges, and they tend to get hand polished. So the traditional way of doing that is they're going to have to get out a big caliper and check some critical dimensions, and that's a very manual process. So something that we could do, haven't done, but could do is set up a very basic version of a machine vision system that has a high-resolution camera that takes a picture of each finished piece and does those measurements automatically. Again, that equipment's quite available. If you're building cars or something like that and you're making 1,000 body panels a month, they're going to have that kind of automation. But we're trying to make it more accessible to the small to medium business where they're doing a lot of manual measurements. And it's not that we're trying to eliminate humans. We want to have our human capital invested in working. We want to have people that are core to our business. We want to take care of our people. But we also don't want to have our people having to do boring, repetitive tasks that are error prone. We'd rather automate those so that we can use our people to do the things that people are really good at and take advantage of their minds and their skills.
Right, absolutely. And in my understanding, what you're kind of doing is building some flexibility into these systems. So in that laser cutting example, that company could use essentially the same system to then inspect a different part. So instead of dropping, $200,000 on this inspection system and $200,000 on that inspection system, you're finding ways to kind of put them together. Is that right?
That's 100% right, and really a great point. We very intentionally, when we build a system like that, instead of, because the simple way, the shortest way to get that thing built is you build in the measurements for the one piece that they need it for. But instead, we'll talk to them about, hey, can we spend a little more time, a few extra hours, let us build a more arbitrary system where you can take any piece, cut the piece out with the laser, put it under here, make sure you've got one right, do your manual measurements. We'll take the picture and try and automatically determine what the critical dimensions are, let you tweak it, and now you have a system that they can throw every piece of sheet metal on that comes off of one of those lasers after the polishing process is done, and ensure that all the parts are the same. Like you say, now they're able to use that for all of their clients, their customers, instead of just one.
Right. And that's really the solution that we're looking for these, high mix, low volume scenarios that a lot of manufacturers are in that have traditionally struggled to get into automation because they just can't justify the cost because they aren't going to have a separate automated solution for every one of their processes. So building these flexible systems really seems to be the solution.
Yeah, absolutely.
So, when you are kind of looking out at the market, it sounds like you could be interested in somebody in that laser cutting scenario, or even a machine shop that is pumping out 100 parts every few minutes off of a three axis machine. Has there been anything that you've been like, man, I would really love to get into that. I could really solve some problems there.
Yeah, actually, that's a really great question. And after a little bit of thought, I think there's There's a problem in the world of consumer electronics. We get a lot of e-waste. There are a lot of things that people get them and they're either too inexpensive and they get thrown away, or they're expensive enough that they use them for a while, and in some cases they trade them up. We have a lot of phones and other things getting used and reused and thrown away, and we end up with a lot of stuff in the waste stream, a lot of things to be recycled. What we're trying to do is make the manufacturing process cleaner, more repeatable, so that we're not losing those products, and so they're not having to be manually tested, because people, frankly, it gets really boring having to test the same things over and over again. So what we're trying to build is something a little bit like what you described with the machine shop, but for electronics. So in electronic contract manufacturing, they have an extraordinarily high mix of types of products. They'll have some customers that build 1,000 a month of something, some that build a batch of 100 of something every 6 months. And yes, you might have a written process for how to test and verify and make sure that what you've built goes out the door correctly. But there are so many parts on those circuit boards that sometimes the test coverage, it doesn't find every little flaw. And then you end up with your customers being the beta testers. You send something out and they end up having to return something, and you don't know for sure, is it because they broke it? Or is this really a legitimate warranty return because it wasn't built correctly? Right. So the little box we're building is designed to make test fixtures that can test these electronic devices. And again, be very generic, like the platform that can test 100 different types of cut metal parts from a machine shop. This can test 100 or 1,000 different types of little circuit boards. It's smart enough to know which test fixture, test accessory has been plugged in, because for example, a little Bluetooth fitness tracker that goes on your wrist, you might need a little cradle that hooks to certain connections and goes through a little box, and then that box will use a very generic cable that plugs into our box. But the boxes are now smart enough to talk to each other and say, oh, this is the Bluetooth fitness tracker, not just the Bluetooth fitness tracker, but it's version A, B, or C that goes out the door. So it tests the right parts for the right ones. And you end up with much higher quality products being delivered to the end customers, much lower fallout rates, and on the environmental side, we end up with a lot less e-waste, a lot less stuff that is either being recycled or, in worst case, not being recycled and ends up in the landfill.
That's fascinating. So, I am not enough of an electrical engineer to understand much here. But so, when you've got so the fitness tracker, for example, you've got, 150 different components on the circuit boards inside of that device. How is your program tested? What is it testing them for? Is the capacitor functioning properly? Like, what is it testing?
Yeah, so in a fitness tracker example, first off, we need to make sure that the charging port is working, whether that's a magnetic charger or a plugged-in charger, so we can measure how much voltage current is being used. Is the tracker actually charging the battery? Right. We can use the Bluetooth interface in the test computer to talk to the fitness tracker. And part of the design for manufacturability, design for automation, is also being built into the software, and our firmware and software team knows and does this a lot. They will put features into the software of the fitness tracker that allows it to self-test. Now, the end user never sees that, but that function gets used in the factory to validate. Is the fitness tracker working correctly? It might be as simple as it puts a message up on the screen that tells the test person, please take the fitness tracker and turn it upside down. Because inside the fitness tracker is an accelerometer, a sensor that detects movement. Right. And we need to make sure that accelerometer is working. Right. So we can automate a little bit by having the computer determine, did the amount of gravity that we sense change correctly? Right. Or maybe we'll take a little servo motor, like from a remote controlled airplane, and we'll make it flip the fitness tracker over inside the fixture. And now we've automated that, and we save the human factor of having to turn the thing over.
I see. Okay. Wow. Yeah, that's some complicated stuff. So you mentioned the design for automation, and a lot of the manufacturers, or I would assume every manufacturer, is familiar with the term design for manufacturability. Is something we talk about a lot. Mm-hmm. What is the crossover between design for manufacturability and design for automation, and where do they part ways?
Yeah, really, the funny thing is, a lot of design for manufacturability, at least in the electronics world, is a huge crossover with design for automation. A large list of the design for manufacturability guidelines for an electronic product are: you can't put components right near the edge of the circuit board because the machine needs to be able to grip the circuit board to put the parts on and run it through the reflow oven. Similarly, when you're manufacturing a part, even in a machine shop, you designing something that's manufacturable often involves making two parts because there's no way to machine a single part.
Right.
So you have to be planning ahead of time, not just what does the product look like, but how am I going to put that product together? Along with that comes things, is the O-ring going to seal properly and protect the electronics from moisture or something like that? That crossover in electronics can be even more intense because there are so many different component suppliers that if you choose a kind of a low-end, bottom-of-the-barrel bargain basement component supplier, you can end up with unreliable components. And it might work, it might test out okay, at least sort of, but it will have a shorter lifetime in the field. So there's also some supply chain management and things like that that really go into building high-quality products. You really need good ingredients in order to build those good high-quality products.
Right, right. I'm trying to picture design for automation in more, kind of diverging from the electronics, because it's a little bit more of an odd use case. But, a lot of the smaller kind of service-based contract manufacturers that I talk to, I'm always encouraging them to do things like figure out how to start tracking data, whether that be, how many parts per hour you're pumping out, whether it be how long does it take to turn over a machine, whether it be, just what's the quality of those products once they come off, how often are you getting defects, things like that. So I kind of consider that tracking data to be step one in integrating some sort of automation into your process. Mm-hmm. What are some things that they could be thinking about along the lines of design for automation that maybe we hadn't thought of? Maybe it's the way that they're designing their fixtures for the parts, or, maybe the way that they're coming out of the machine after it's done. Like, what are some things that you've come across?
Yeah. So one of the things that really seems to be a trend really is tracking each individual product as it goes through. Now, you might be talking a large product, a small product. Of course, barcodes, QR codes are a really great way to do that sort of thing. The QR code may contain something as simple, small, and basic as it's simply a lot number. But it's also helpful as you try to build out your process to have additional information, metadata, if you will, be captured. Now, it doesn't have to go into the code itself. The code can really just be a serial number, as it were. But you need to build just enough computer back-end support so that instead of simply pulling a piece of raw material off of the in box and putting it on the machine to be done and then putting it on the out box, part of that first level process is I'm going to put a QR code on there, and now at every subsequent step we're going to scan that QR code. And that's nice, that gives you a good starting place, but there's a lot of additional information you can now connect to that. Right. Who was the operator? Who was working on that machine? What was the machine? You might even want to mark your tools. I mean, in the case of a 5-axis milling machine, you want to keep track of which milling heads are being used, because what if some of them are wearing out and now we're suddenly getting a worse finish, or our tolerances aren't quite as good? Well, now we can track it back to maybe it was an operator, and it's not to go and get after the operator. We're not trying to get them in trouble, but we're going to do some better training for them, or we're going to swap out the tools or sharpen them, or also we want to be able to track back to the lot of material. Where did it come from? Did we do an incoming inspection on the quality of that lot of material when it came in the door? And now can we track an end product all the way back through the process to the raw material and every step along the way?
That's a very interesting concept. And I had a recent podcast with a guy, I think we just posted it, that's developed a procurement platform. Mm-hmm. And that was one of his big value adds, was being able to track, the part or the component that you ordered, and track it all the way through production and know exactly, when you've got a batch of parts that are wrong, what component went into that. So that is a really interesting thought.
Yeah. Yeah, that's part of that automation process, is knowing what came where. I mean, most people, when they're trying to launch their company or their business, they're focused on just getting a product out.
Right.
And that is, and it's got to be a great product, because you only get one chance to make that first impression with the customer. And some of these things end up being an afterthought. And eventually you add that kind of automation, even if it's just some basic data tracking. But if you'll take a few extra steps at the beginning, even if you're building your very first widget, whatever it is, start a Google spreadsheet or something like that, and try and manually track at least some of this information. And it will give you some ideas about what you can automate when you are ready to ramp up a bit more. And also, hopefully, provide you with enough of that information that if you get your first defective product back, you have some idea of why.
Right. Yeah, I mean, it makes perfect sense. And I always love these examples of specific things that you can start doing to move towards automation. I firmly believe that it's going to make the difference in the success of manufacturing in the U.S. versus the failure is the degree to which manufacturers can automate. We are not getting the labor shortage is not something that's going to go away. And when we compare ourselves to China, for example, some people have stated that they're 80% automated, which is a little bit difficult to measure, but essentially they're saying 80% of their production is automated all the way through, whereas in the U.S. it's somewhere between 7 and 8%. And so that speaks to them being able to produce, in a lot of cases, a higher quality part, which is something we haven't known China for, at a much, much cheaper price.
Yeah, and that is really the case. They have, we don't have a lot of visibility to it from what is actually happening in factories in other countries. But from what little we've been able to glean from the products themselves, as well as what little video or photographic information comes out, they are really have been for quite a few years, been embracing automation in a big way. I think early on, when they had large numbers of people available, they did a lot of things manually. But as they ramped up, they realized the value of automation in terms of improving quality. And while a lot of foreign countries have been known for poorer quality products, you'll also find that some of those same countries also produce some of the highest quality products that we import, because they use so much automation, because they have become very skilled at that. And I agree, we really need to bring a lot more of that automation home and grow our own manufacturing base that way. We're trying to do some of that right here. We try to work with contract manufacturers that are a little bit closer for a lot of reasons. If you're on one end of the political spectrum, you care about that simply for the dollar cost savings. And on the other end of the political spectrum, you're more interested in that because of the environmental savings of not having to ship the products around the world.
Right. Yeah, that's absolutely right. And it's interesting. To me, it seems like the trigger for automation would be a lack of labor resources, or one of the main triggers. And so I've always found it interesting that China got on the ball with automation so quickly when really, they're just starting to run into some major labor shortage issues there because of the one-child policy, et cetera. But they've been on the ball for a while now. And we have been suffering from a labor shortage for, close to a decade here. And we're not really moving very quickly. Why do you think that is?
It's a really great question. I think the inexpensive goods that we've been able to buy internationally have certainly fueled that here. We have had less reason to automate because, it's a lot cheaper to just go and buy the inexpensive imports. So for better or worse, the effects of tariffs and other trade barriers are forcing the country to try and get a little bit more cost-reduced approach to manufacturing things. And it's going to be interesting to see how that plays out, because some manufacturers are probably going to go the route of cheapest fastest, try and grab market share with potentially low quality things. Others are going to go the other direction and come out with the highest quality, best products that we can find. And hopefully the market, the people, will decide that they want to support the businesses that do a really good job, that take really good care of their customers, not just in creating the product, but also their support and service of the customers. I think that if the market rewards companies that are doing a good job in every way, then as a country, we're going to go in the direction where that's a positive thing and people appreciate and are rewarded for doing good things.
Right. Okay. Yeah, and I agree with that. So what makes a good customer for you? You know, somebody's in the audience and maybe they're not in the electronic space, or maybe they are. You know, how would you like to engage them? Who would you like to reach out to you, and how would you approach that? Do you go into their shop and evaluate what they've got going on? Like, how do you work with people?
Yeah, the amazing thing is we've never advertised. We work completely under referrals that we get from other organizations, and we've been quite successful that way. If anyone cares to reach out to us directly, we are happy to discuss the needs of their product. And you'll find that I hope we're a refreshing approach to this. We're very different than a lot of companies. Instead of being the kind that's, all right, great, how can we get this opportunity? We got to take advantage of this one. We're very much the opposite. And if we're not a good fit, we're going to suggest that we're not, and that we'll try and connect you with somebody who is. But anybody who is trying to ramp up their business, they're trying to build something that they haven't been able to before, and they are just not finding a cost-effective way to do so. And yes, there's going to be some investment up front to do that automation, but when they do, it will pay off in a big way. There are a lot of aspects to running a business, running a company, and balancing all of those requirements. Everything from legal and regulatory to creating a good product to taking care of people. It's very challenging to balance all of that, and perhaps we can help with some of the automation. We can offload some of that effort, but you'll find that we're the kind of people that are not trying to pull it away and then make you dependent on us forever. Instead, we're trying to help you build the company back and help you build your own team so that you can take what we build for you and take it to version 2, 3, or 4, even if we're not around. Or if you prefer, we're happy to continue growing with you. We have some customers that we've been working with for over a decade, and they continue to have us do large amounts of work every week, every month. We have others that come in, they have us do one quick, simple project, and we're done and out the door, and they keep going their happy way. And we're hoping that they go out, grow their companies really big, sell them, get rich, and then start their next company and come back and ask us to help them again.
Right, right. And it seems to me that, you know, that the job shops that have, you know, kind of had their eye on automation and have not really found a good solution because, you know, they go to an integrator and they're like, well, we have, you know, this $50,000 robot, and, you know, we're going to integrate it and we're going to, you know, come back every year when you make adjustments, you're going to have to pay us to do that. Those types of companies that have traditionally struggled to get into automation, it sounds like they would benefit from at least a conversation with you to kind of just take a little bit more consultative approach and see if there's a way that you can create a flexible solution that's going to help in multiple areas of their operation.
Yeah, and we're happy to do that. I don't want it to end up being this being a commercial for us. So let me also explain another approach that can also be very effective for companies. So maybe we're not the right fit, but take a look around at some of the vocational schools, some of the universities that offer automation. I know of a couple, in fact. Some of our kids have been involved in some of these programs as they went through college, where they have been trained on automation of various kinds. Right. And in a lot of cases, those are actually very focused more at the machine shop kind of world, the large industrial equipment kind of world. In our case, we tend to program on small embedded computers, microcontrollers, small embedded PCs. But in those industrial automation programs, they're really focusing on what are called programmable logic controllers. They're boxes that are really designed to automate a robotic assembly line, basically.
Right.
And perhaps for somebody who's just trying to get started in that area, and you maybe don't even have the budget to spend on any automation, take a look at some of those and see if there's an internship opportunity that you can offer to a good student or two out of one of those vocational schools, and have them come in and budget enough to let them buy some equipment and see if they can put together a little bit of automation to get you started. And it lets you just dip your toe in the water in automation without having to go whole hog and commit to a major investment.
Right. Yep, that makes sense. And there's some great programs out there. I know that there's some organizations that are aggressively trying to get kids into, robotics and automation. I work with the NTMA quite a bit, and they're involved with this program called RoboBots. It's a huge growing initiative, and a lot of kids are kind of building their own robots and exploring different use cases with them. So that's really neat. So Jeremy, I always like to kind of wrap up the podcast with a session that, if somebody's listening and they can, be helpful to you in any way, whether it's, being a customer or providing you with a solution that maybe they could reach out to you. So is there anything that you've been kind of actively looking for, maybe, a collaborative partnership, or maybe a manufacturing service provider, or a consultant, or an employee? Is there anything that you've been kind of keeping your eye out for recently?
We don't have anything specific that we're trying to reach for. We continue to have a good steady stream of business coming in from referrals and all of that. So it's kind of like being asked, what do you want for Christmas? And saying, I don't know, or I feel like I'm doing all right in that way. What I think we'd love is simply to get a chance to talk to people. It's fun to get to talk about their ideas. And sometimes the ideas may or may not be a good fit for us, but it's so much fun to just get to discuss with them. We can often give them ideas of how to pursue their dream, even if we're not the right people to help them out. Someone comes in asking for something that's just a complete not fit for our team and what we do, but it's still fun to discuss it with them, and sometimes we still come up with ideas that help them along that path. So perhaps just anybody who has ideas, thoughts, something they want to build. Yes, we tend to be more electronics and smart things and stuff connected to the internet, but anything that has an electronic aspect to it it's worth having us discuss it at least. So we're happy to talk with people, and if there's someone out there who has an idea and would like to be a contributor, please come talk to us. Let's chat and see how it could work, how it could fit in. We don't have any it's not like we have a sales force or anything like that, but really our friends and their friends and their friends' friends are the ones who continue to bring work in here for us. And it's that personal referral relationship that really helps us work well with our customers. So nothing in particular, just keep bringing the fun projects our way, because we love what we do.
Absolutely. And that speaks volume that you are able to, kind of operate on that referral basis. It seems like it's becoming increasingly difficult for a lot of companies out there to do that, just because as hyper connected as we are with this digital technology, we're also separating from each other in terms of, the face-to-face meetings and, the relationship sort of stuff. So that is impressive. Well, Jeremy, thanks a lot for coming on. I would encourage anybody that was listening to reach out and just have a conversation. I'm sure Jeremy's going to have some interesting things to share. Pretty cool business you're running there. So thanks a lot for coming on, and look forward to chatting soon.
Thanks so much, Nate. I appreciate it. Have a great one.
You too.